Hi, in this video, I'm going to demonstrate how to use the 3D scanner to scan the small football, then generate the model which can be used to 3D print the replica later. On the left, we have the turntable called AutoDrive. We'll place our football on it and fix it with the holder. On the top, there's a small rod. So that one supports the object stay on the plate steadily. You will want the object spin with the auto drive without falling off. The next engine software will control the scanner and process the modeling. Before the scanning, we need to set up the software. Here we have multiple options. In the positioning option, we have 360 degrees, bracket, and single options. For example, by selecting 360 degrees, the turning table will rotate totally 360 degrees and each time a specific angle. The bracket setting means it's not a full turn, but several sections in specific angles. The single option is only for scan the surface face to the camera. Therefore, you have to spin the object manually if you want to model the whole object. Below the positioning option is the divisions option. That defines how many angles the turntable spins each time. The minimum is 4 and the maximum is 16, which means if you set the division to be 4, each time the turntable will turn a quarter of 360 degrees, that is 90 degrees. Then if you set it to 16, each time the turntable will turn 22.5 degrees. Next, we have the resolution settings. So here we have quick settings, which give you the lowest resolution, but the speed is very fast, and then SD and HD. But the higher resolution, the longer scanning time it takes. The bar under here gives you the estimated scanning time. Below the resolution option, we need to select the condition of the object. Here we can select like a natural, dark, or light. That kind of set up the camera's exposure time. Lastly, we have the settings for the camera's focal point. For example, if we have a small object, we want to select the micro, and it suggests the ideal distance between the object and the camera should be 6.5 inches. If you have a bigger object, you may want to use the wide option. Then you can see the focal point will be way farther than the previous option. It suggests to be like 17 inches away from the camera. Here we just switch it back to the micron option. And we have another settings can do. So as you can see, the picture includes everything with the turntable. But we can actually only select the item we want to be scanned. By generate a frame here, the software will ignore the parts outside the frame. Even you don't generate this frame here, the software later have the function to trim the unnecessary part off from the final model. Since this is just a quick demonstration, I will set the option to single, then scan two sections of the object. After that, I will combine the two parts together to show you the basic procedure of the 3D scanning. In the yellow window of the software here, you can see the procedure of the scanning. Now it's in the first step capturing 2D image, which means later the model will have the texture information of the original piece. Now the message in the yellow window shows it's starting the 3D scanning now, and you may notice the laser beam from the scanner is shooting on the surface of the object. It basically measures the distance of each point on the surface away from the camera or scanner. Then the software will process these values to the coordinates of the system, then build up the model. Now we have the first section scanned. We can drag the model. You can see it has not only the shape but also the texture combined on this model. On the toolbar, there are functions like trim, fuse, and polish give you the ability to modify the parts before you combine them together. Here, let's go into the trim function. Then you can rotate the scanned model. You can see the small tip here. It's like a part of the holder, not the object. So I just select it and it turned to red. You can also deselect it if you want. But by clicking the trim button, you can see the small tip is eliminated. Alright, now we can manually switch the direction of the object, then scan the section next to the previous one. Then after we get the new surface section scanned, we will drop some pins like reference points onto the two sections. Then the software will know how to combine those reference points together, then generate the final model. That's why we put these marks like cross marks, dot marks, and numbers on the surface. That just for the reference point later used in the software. Alright, let's scan the new section. Here I'm going to skip the scanning section and jump to the combining section. At the bottom you can see we got another piece scanned. In the green zone we have the first section. We will combine this one with the second one. There's a Align button on the toolbar. After clicking it, the window split it into two. There are three pins with different colors on each window. What we are going to do is drag the pin and drop it on the reference point of the one section. Then in another window, drag the same color pin and drop it to the same spot on the other section. Here, usually I will choose the feature that can be easily spotted, like the tip of the white mark here. You can zoom it in and zoom it out to find the spot. Then we go to the next colored pin, the yellow one. Then we will choose, for example, part of the number 3 and drop it on both scanned sections. Lastly, we are going to place the blue pin, and here is another suggestion. Try to place the pins in triangle, not in a line. Otherwise, the software may not have enough information to combine the two sections in 2 dimensions. You may also notice there are 3 new pins with different colors on the screen. which means you can keep dropping more pins on the surface to generate more accurate combination. Here I'm going to drop several more pins. Alright, I'm going to click the align button. Then the two scanned sections are all into the green zone right now. That means they are already combined together. So you can see in the main window is a whole part of the two pieces. Then, in order to get the whole piece, you just need to repeat all these procedures until you get all the directions, then combine them together. And for the top and the bottom part, so you want to line the sample down, then scan those two areas, then combine them together with the others. Go back to the settings. Of course, you can choose bracket way or the option of 360, which means the turntable rotated the object instead manually rotated. So that's more convenient. Here is unnecessary to show all the procedures because they basically has the same concept with the manually one. So I'm just going to show you how the rotation table works. As you can see, it's spinning in the angle we set. Here I set the divisions to 4, so each time the rotating the turntable just rotate 90 degrees between each sections. Also, the software automatically generated the alignment instead of you manually choose those pinpoints. Here we have the final outcome. You may notice there are still some misalignments just because it's a quick demonstration. In the real application, you may need to increase the resolution and increase scanning sections to get a better quality. You can definitely get that. Also, as you can see here, the software provides the ability to re-edit the files using the scanned data. For example, you can realign the parts together, or you can just use the trim function to trim the unnecessary parts. You can select and deselect. After click the trim button, it will get rid of the parts you don't want. And also, as you can see, as I mentioned, there are like fills and polish options. All these functions help you to optimize your model before exported. Now after I click the output button, or you can just click save as, so you can choose a STL file as the saving type, then export the model for 3D printing. Here I just use the Cura Slicer software to open the STL file, export it, and you can see it has the features from the original piece and it's ready for 3D printing. Alright, that's the demonstration for today. Thank you for watching and good luck.